Hello, welcome to another session of the Houdini Training. My name is Gianvito Serra. Today we're going to actually learn with this, we're going to just have a small session just looking at multiple surface operators which are available in Houdini. The goal of this is basically just to help build a little bit of vocabulary on some of the operators which you can use to do different things in Houdini. I know one of the biggest difficulties going into any application really is to actually learn the vocabulary of the application, right? Learning which nodes you can use to do what operations or whatnot. What I like to do here is to actually just spend a little time giving you several geometry operators which you can use to do certain things. Now, as explained before on my sessions about the basics of nodes, nodes have a state, nodes do take geometry, they either create or destroy, create or modify or destroy geometry. Surface operators do. And they all have some state that is the actual active tool state. Okay, so what I want to show you here is just what the nodes do, some of their parameters that they have available, as well as what their active tool state actually does. Okay, so let's get started. We'll start with just a simple tool, and just to show you really quick what we're gonna do, we have just several little networks inside of this scene which do, as usual, a small series of operations to show you what certain operators do. Okay, let's start with just this, the tube operator. So the tube operator is one of the many primitive nodes that are inside of Houdini. Okay, so we have tubes, we have also, if we go on the primitives, we have circles, we have spheres, and so on and so forth. Many of these can actually be created in multiple ways. Like this is a primitive circle, which is just an OpenGL display type circles, but it can very quickly be switched to polygons, or it could be switched to NURBS. Okay, very cool. Now, most of these operators will have certain options that you can actually control for the creation of the operator. So for example, the tube by default will look something like this, which is a primitive tube. Always remember to check that your tube, your primitives, if you're going to operate them, they're not set to being just a primitive type, because most likely they will not be able to modify them with polygon modifiers. So if you're going to modify them with polygon modifiers, you may want to set them to polygons. Of course, you can also do certain you also have modifiers which will apply to NURBS, and so on and so forth. Okay, but for this case, we'll just use polygons. Okay, and in this case, we'll turn on the end caps. A lot of the primitives will also allow you to specify the direction of a primitive that you want to work on. Okay, so the dominant direction, and then you will have operations such as the radius, which you can generally operate in different settings, or even the location on the center and stuff. Most of these operators will also, if we click on the handle, will have some kind of like UI controls that we can actually operate on. Okay, these are actually active when your node is selected and when the show handle option is selected. Okay, so for example, we have here operators which allows us to change the center settings on the fly, as well as the actual height and scales of the actual cylinder. We can also, sometimes we'll get also these sliders down here, which we can use to increase the number of columns and also the number of rows, for example. Okay, very cool. Reason why, by the way, this also looks shaded a little bit is because we're actually consolidating the corner points in here. We can keep them non-consolidated if we wanted to, and which will create a nice hard cusp edge here. Or we can even keep them consolidated with add vertex normals, which will give us a hard edge, but it will do it by actually splitting the normals for each per vertex face in here. Okay, very cool. Now let's move to the next one. Next one that we have here is the polybevel. Polybevel does what you can imagine is a bevel operation, okay, which can be done on edges. it can be done on points. You want to pay attention to the settings that you have here. You may first drop this operator and it may look like this, and you may be wondering why your edges are not beveling. It's because it's set 2 points. Switch it to edges, then all your operations will work on the edges, okay? Now, any of these operators, although I'm actually operating here on all the edges, can be filtered using groups by edge groups, for example. But at any of these operators, especially if you're in Houdini 15, it will have the group field will actually have a little arrow here. Okay, you can click on this arrow, and that will allow you, will put the tool in a state, which will allow you to actually pick edges or points or whatnot. Okay, so we can switch here to edges, for example. Pick a few edges here that we want to extrude, and then press enter. And now the extrusion will only work on those edges, okay? Now what this will do is that it will actually create a manual group, which is basically just a list of points that we are extruding, okay? Be very careful when you use this. Remember that your groups that are actually based on point IDs are not necessarily procedural. If the tube changes edge, if you actually change the edge loops on the tube, you know, obviously you're going to modify your geometry and your extrusion may shift, okay? If we actually use more procedural groups, you will not have that problem, okay? And for more information on groups, please take a look at the videos that discuss the group sections, okay? Let's just move along a little bit. I'm going to go ahead and take the group out here, okay? Then let's go to the next operator. I'm going to go ahead and actually keep my bevels to about this. And then the next one that we have here is the normal operator. The normal operator is a great way to actually add normals in different ways to operation. We can, for example, use this to add hard edges based on an angle. We can also force the normals to actually work on points or to actually work on vertices. We can even force the normals to be on primitives if we really wanted to do something very strange with your normals. But it just allows you to do some level of normal manipulation, and you can again, you know, filter your manipulation based on groups. Okay. Cool. Moving on, the knife operator will allow you to slice an edge around the surface. You can actually move their little operator right here, and even rotate the actual axis of the operation if we wanted to actually do this. Okay. It's very straightforward operator. You can of course control the operation using also the parameter view here, and you will see that the edge always flows here as we're actually moving. Again, all of these operations are fully persistent, so if we come back to our tube and increase, you will see that the knife operation is still working as expected. Okay, very cool. You can also create groups. Most of these operators will allow you to create groups, which then you can use to filter operations down the line. Okay, awesome. Moving forward, here is the subdivide operator. You go ahead and actually hide the knife operation so you can see a little bit better. Subdivide operation does what you will imagine. You know, it takes a geometry and it subdivides it to add edge loops on the actual mesh. Let's go ahead and actually also make the normal operation so we can see this a little better. You can see that as we add divisions, we are just subdividing the mesh. If you're coming from Maya, this is not too different from the smooth geometry. And then let's say that you have several options here, and you also have several options here, such as being able to use open SOPs, for example, instead of actually using Houdini's Clark. Okay? Different options that we can actually go about doing our subdivisions. Okay. You can also use crease weights to actually say how much each one of the hard edges are going to crease, and so on and so forth. Okay. We have the fuse operator. Fuse operator just gives you multiple ways to actually use fuse points based on distance. Okay. There's multiple ways so we can go about doing so. You can also do this operation, which actually just snaps them but doesn't fuse them, so that we keep the original points, or we can simply consolidate them. Okay. There is also a pulley reducer, which will pulley reduce the actual geometry down based on percentage, number of polygons, the distance from a camera, or even a list of edges. These all have options to, for example, allow you to keep more equal edges, and also you can use a wave map to actually drive where you want to poly reduce. Okay, but all of these little sliders will give you a little bit more control of some of the things that we can do. You can choose to pre-triangulate or not, or even to use original points. Okay, polywire operator will take any wireframe and actually create a wireframe like this. Okay, which is very nice for actually sometimes creating like wire-like structures. Beautiful thing again is that this is all fully persistent, so we can, for example, mute or subdivide and we get something a little bit more clean. Okay, can even mute or bevel and get something even more clean here. We can still access our operations from the original tube operation to be able to actually go back to this. Okay, now the polywire itself has an option, allows you to control the wire radius, so we can have thinner or thicker actual wire meshes. Okay, but look, even so, for example, turning on the knife operation will actually give us the edge loop that was created by the knife. Okay, then we have again the normals up to clean some of the normals on the operation that we just did. And then the clip operator is very similar to the knife operator, except that it will allow us to actually clip the geometry below as the plane actually goes through. Okay, it's very useful for actually clipping geometry up in certain points, and it even works, you know, when you're actually just clipping just points in a point cloud. Okay, very cool. And again, you know, similar to all the other ones, here is the parameter window, which you can actually use to control this, or use any of the widgets that we have here. Okay, you may keep in mind that all of these operators will also have, again, a group which you can specify to say which faces you want to actually operate upon. Or, if you like, you can always click on the little question mark here to load the help for that particular operator. Okay, and a lot of these will even have examples here, which you can actually load to see examples of how to actually use this operator. Okay, very cool. Now moving over here, let's take a look at some of these operations. So the curve operator, as the name implies, allows you to create curves. Okay, you can at any point just drop a curve operator. Okay, when you enter the tool state, okay, it will allow you to simply draw points either in 3D space based on the draw planes. All of the points are actually stored as parameters, so they are fully parametric. You know, as we modify points, you will notice the parameters change on the fly too. You can even come in here and change parameters here if you wanted to change them that way as well. Or you can even clear this whole curve if you don't want any more of the points. If we have a grid, the points creation will stick to the image plane, just like to the grid plane, just like any other construction thing. If you hold Control, you can also move off the plane, or I believe it's actually Shift rather. Sorry, if you hold Shift, we can move the construction plane, and so on and so forth, just like any other operation. Okay. You can draw all sorts of curves. We can also draw merge curves if we want. We can have them open or close. And even after we draw them, we can modify them, or even shift click on a curve to, for example, add new points. Okay. Very cool. So some of the things that we can do here, if we have two curves and we merge them together, we can connect them together we can connect them together using a skin operator. But the skin operator, let me show you a bit more. If we actually take that side, combining with this side, so that we have something that looks like this, a cross section, skin operator will create a surface that kind of matches what the cross shape actually looks as close as possible. Okay, the curves don't have to touch. It will actually create a polygon patch to try to match that shape as much as possible. Okay. You can choose how you want to connect how you want to actually set up your connections, whether you want to preserve the shape or not. Okay. Transform nodes we have used quite a bit. They allow you to move things around, translate things, but you will notice that as we translate the curves, also the patch that we create is modified. Okay. Moving along, we have, actually let me go ahead and do this, the poly extrude. I have an old version of the poly extrude here, which I'm going to delete. This was updated in Houdini 15. But the poly extrude, the new poly extrude that we have here, this is the extrude operator that is used for doing like your typical polygon type extrusion, like for poly modeling. Okay. It has a lot of really powerful options, which we can use for actually doing our extrusions, such as, for example, being able to choose an inset for the extrusion, which is sensitive to the actual edge loops, so that they don't get actually, so that edge loops are maintained, and also being able to add divisions in between, our extrusion. Okay, we'll go into a little bit more detail on some of the things that we can do here. But this operator is basically an extrusion node in steroids. It has a lot of controls which you can use to control all sorts of things, and we can even control. We can even use attributes to control things such as the extrusion distance, the inset and amount, etc., etc. Okay. Now we can also control whether back faces and front faces draw, which will become handy here in the next operation. The cookie SOP is the Boolean. If you're looking for a Boolean, the cookie SOP is what you were looking for. Okay. The Boolean in Houdini is actually not too bad. It can be a bit finicky at times, but it is definitely, in a lot of cases, it's actually well behaved. A good rule of thumb when actually working with the Boolean in Houdini is to try to keep your mesh as clean as possible. Okay, so if we reduce our divisions here, just work with a very simple mesh, maybe keep our inset at 0 so we don't have too many crossing polygons. You notice that the cookie will generally be a lot more behaved, a little better behaved. Again, it's one of those operators which can sometimes cause some problems, but in some cases, when used carefully, can actually be very powerful. Okay. In fact, I think part of the reasons we're having difficulties here is because of the cusping. Let me turn it off. Let's see. Nope, still a little bit problematic, but it can also allow you to do union. It allows you to do intersections, to return intersection of operation. It's fully persistent like anything else, so that if we actually move the actual object around, you can see the operation still works. But again, it's one of those operators you definitely want to use with care. Okay. The fuse operator, who I showed before, who we can use to actually fuse polygons. Okay. And edge cusp allows us to break edges based on either a group or just break all the edges in general into individual polygons. Okay. The delete SOP allows us to just delete objects. It has some really useful utilities, such as being able to delete objects based on a bounding area, which makes it more persistent than just having to do it based on ID. We support many ways of actually doing this operation, such as, for example, even being able to delete based on the direction of a normal. Like, for example, we can make it so that it deletes any polygons which any points which have normals facing upwards. and so on and so forth. So basically ability to delete stuff based on rules. We'll cover the model divide operator in a few sessions here, but it's a very good way to actually do triangulation, in addition to some other operations that actually not subdivide but divide the geometry in many different ways. Okay, you can, in addition to actually triangulate, you can, for example, do brickering, which allows you to put almost like a grid-like pattern on top of your geometry, which can be useful in some situations. But we'll go a little bit more into some of the things that we can do with the actual divide sub in a few. Looking a little bit more, the font operator allows us to draw fonts in 3D. It is a fully persistent operator. It supports expressions just like anything else, so that we can put, for example, a frame number and actually be able to switch a frame number on the fly like this. Okay. We can support any kind of font that we have installed on our machine, as well as being able to support the scale for a font, being able to support being able to do them in an oblique angle, and a level of detail if you want more or less points. Okay. The reverse operator, if we look at the normals on the polygons, allows us to reverse polygons. Okay, so if we look at this operation, we can, for example, reverse polygons on either the U or the V, or we can even swap the U and V or shift polygons around. This is very useful, for example, to adjust winding on polygons if necessary. Okay. The facet sub allows us to do a number of operations, such as being able to, for example, remove inline points, which allows us to actually remove points based on their actual, how much of an angle there is in between them. As you can see here, it's very useful to grab all the points which are straight and actually remove them so that we're not actually wasting polygons when we don't have to. Okay. It is also useful, for example, if we have a sphere, polysphere, and say we needed every point to be a unique point. Okay, right now each point is fused together. Say we need to separate them for any reason. Adding a facet and setting it to unique points will allow us to break every point so that every facet is completely unique. Okay, so a lot of very useful operations related to actual polygon facets. I recommend looking more into this operator. It's one of the ones that I use a lot. Cool. Now this right here is the legacy extrude operator. Although it's legacy, it still has a lot of really useful operations behind it. So one of the things that I like about it is that it is very sensitive to parametric surface operations, and it supports also the ability of not a spine curve but an inset curve, which will actually inset your polygons based on an actual profile. So as we move the points in this profile, you will notice that we're able to easily modify how the insetting or outsetting of those polygons works. Okay. The extrusion depth can be controlled here as well, and similar to the other extrude operator, you can also choose to whether you want to output the front face or not, and whether you want, for example, to use output rows and columns as your facets, which can sometimes be very useful. Okay, and you can control. There is several controls that we have here for controlling the thickness and the actual depth scale, as well as we wanted to actually put hard edges on the actual polygons. Okay. Now this is again fully persistent with the font sub, so if we actually went in here and started moving the frames, all of this will change. If we came in here and actually changed the text, this will all still work. Okay, beautiful. Now here is again the divide operator, and what I'm showing you here is how we can use the divide operator to triangulate these faces in a way that works very cleanly. Now, in a particular case, I only want to triangulate the front faces, so let's do that really quick. I'm going to create a group here for my front, back, and side faces, and I'm just going to tell my divide sub to only do the triangulation on the front faces and the back faces. There we go. The triangulation that it does here will keep actually a really nice triangulation. Now it can also support doing different counts, but this is when you're actually increasing your maximum number of edges, what we are doing is that we're actually just enforcing convexity on the actual meshes, okay, versus 3 edges enforces clean triangulation of 4 meshes. Okay, let me show you the triangulation with another font. Here we'll just do the Arial to see a little bit more clear. And here we are. Okay, all of this again fully persistent, even with being able to play with the level of detail of the actual font. Cool. The twist operation, as you can imagine, will allow us to add a twist to any mesh. The smooth operator will allow us to also add a smoothing. And if you smooth a lot, of course, you may actually lose your meshes, depending on the actual settings of your smoothing. Allow for cutoff frequency, you may keep things a little sharper. If you want things to be very soft, you can actually set it to 5, and then things will get very, very soft very quickly. The bound operator will return the bounding, an oriented bounding box, or just a regular bounding box of the incoming mesh. You can also do a bounding sphere, for example. And the neat thing is that the actual, font size scales, you notice that the bounding sphere actually matches the font. Okay, you can see this a little bit better here. Back to our bots, and then here is the divide sub again, but this is the brickering operation that I was talking about, where we can actually add almost like a grid-like subdivision on any mesh, and even add an angle for rotating the actual grid that we want to actually apply. The angle can be done on obviously individual axes as well. But another very important operation of the divide sub is the ability to do this. So if we grab our font operation and put a divide to triangulate it, the font operator will also allow you, the divide operator will also allow you to remove any edges which are inside of your mesh, only leaving you with the outside edges by doing remove shared edges. It's a very useful operation if you have, for example, a grid, and even if your grid has a little bit of noise, using a mountain operation. Okay, you can always use the divide operator, for example, to return only the boundaries of that. Okay, which is very, very useful in a lot of cases. Okay, and cool. Moving along. Here is another example of the extrude from Houdini 15, used on a sphere. You can do some really interesting effects using this poly extrude. Okay, and I'll just show you some of those things right now. Go ahead and actually go ahead and start with a new extrusion so we can see this a little bit more cleaner. And just show you some of the different options that we have. So by default, if we actually just extrude this sphere, it's just going to get thicker. But we can switch from working in connected components into individual elements, okay, which will give us this. A lot of the controls that you normally use will be here, so that you can actually control them right from here. So that's, being able to control, for example, the number of divisions that you wanted to actually go through. Okay. You can also at any point add twist to any of these operations, in addition to be able to choose the amount of insetting that we want to do. Okay. We can get some interesting shapes out of this, but you can obviously do more practical uses, with all the controls that we have here. We can also go to spine control, and even, for example, control the thickness via an actual thickness ramp, which will give us a lot of minute control of how we want the actual thickness to be affected. Click on here so we can see this a little bit more clear. In addition to this, any of these ramp operations have a lot of very, very specific controls which we can actually control, such as, for example, how this actually will blend in between the different points, which obviously are bound to the effect of the actual number of polygons we have. And for example, being able to similar control for example, the twist. Okay. Some really cool operations that we can do here. That again, in a lot of cases you will have probably something more practical that you may use them with. You can also, of course, control not the actual insetting, with the actual the way how the actual spine travel with a curve such as this one. So it'll be hard to see here, but here, let me just show you this. And then if we actually turn on the spine shape to be curved from the second input, you will notice how here I will go ahead and just draw a new curve. You will notice how we can use this curve to actually control the shape of our extrusion. Okay, and again, it's all fully persistent, so that it's never too late to actually change how we do our operations. Okay, reduce a little bit of the insetting that we have here. Okay, moving on. Another new operator from Houdini 15 is the, let me switch back to perspective view, is the pulley expand 2D. Now, pulley expand 2D allows us to do is a straight skeleton operation on a particular curve or shape. Okay, let me just start this in the beginning. So starting with our curve that we have here, pulley expand 2D will allow us to expand it in this particular manner. Pulley expand 2D can be very useful, for example, for carving out roads, for doing different operations which require, distortion of a curve. Now, there is different ways how this works. For example, we can do it with offset curves, or we can do it with offset surfaces, okay, which will actually create edge loops like such. Okay, and we do it like this. We can even add divisions in between those curves. Okay, we can do it with single curves, or we can do it even with shapes such as this. Okay, this is very useful, for example, for building roofs. We can also choose, in this case of a shape, whether we want to output the inside or we want to output the outside, or both. Okay, we can create groups for those, and also an edge distance attribute which we can use to lift this roof. Okay, so very, very useful operator. It's a great addition to the family of operators in Houdini 15. And I highly recommend you experimenting with it. Okay, another very useful and unique operator of Houdini is the trace operator. Trace operator will allow you to grab any image and be able to actually trace it with geometry. Okay, you can simply point it to any image, like for example, the mandrel from that comes as a default image in Houdini, and actually create geometry out of it given a threshold. Okay, and either add point texture settings. Let me see, pick, and adjust, how much of an effect you want from the actual tracing. Okay, you can also add some filters for cleaning up, for actually resampling shapes right here, for example, to cleaning up your shape, or even for actually doing smoothing on your shapes if you want to. You can force the actual shape to fit into a NURBS curve, or even and then convert it back to pulley if you want to. Okay, if you have shapes that go on top of shapes, you can create holes on your shape, which in this case we don't have to, but this is some of the things that we can do here. Okay, can also use another very useful operator is the resample operator. The resample operator will take a curve and allow you to segment it based on a rule. So in this particular case, for example, I'm saying, okay, I want the spacing between my segments to be 0.032 units. Okay, I can also force this curve to be only these many points. Okay, and this will control how this actual curve will get segmented. Okay, you can also force the last segment to always be there, which gives it just a little bit more evenness. You can force it to just create a point cloud out of this, and so on and so forth. There is several options here that you can use for actually controlling this. You'll notice that now we end up with a straight point over here, which we don't want. There's an operator called the clean operator, which will clean most problems that you may end up having with meshes for any reason. Like you can be used for forcing manifold only topology. It can be used for removing attributes or group. You can also use it to reverse one in order to fix overlaps of meshes. Okay. It's also very useful and a very cheap operator to use. Now that takes me to another one, which is also useful when dealing with curves. The curve operator will take any curve or any NURBS shape and allow you to carve a patch or a segment in the U or the V. Okay, in the case of a curve, it will work like this. In the case of a NURBS patch, if we start with a sphere and set it to NURBS, and actually put a curve, this will allow you to actually pick up a square patch in between the U and the V. Okay, which we can move with this. And also, if you want, create the breakpoints for those as well. You can also use this, for example, to just extract curves, in case you need those curves for any reason. Okay, they don't have to necessarily be used for actually cutting patches, and you can even keep the original mesh with the curves if you really want to. Okay. Very cool. The polywire operator we saw before, that we can use to actually create a polywire of any kind of curve. And similar to that, I remember we can always use poly expand 2D in combination with this to do some interesting work with our shapes. Cool. The ripple operator will just add a little bit of ripple noise to your mesh. It's a little bit of a ripple effect. Very cool. Moving along, here are some operators which are generally used interactively, but you can also use, procedurally in some cases. So the bots primitive we're familiar with, and remember the bots can a lot of these primitives will have this manipulator, which is very handy for making these bots or spheres the proper size. Okay, the edge divide operator will allow you to add a division to the mesh, or even choose how many divisions you want to add in between edges. Okay, Similar to all of those operators, we can actually come here and pick the edges that we want to divide. Or we can of course pass an edge group to actually do so. We can choose to connect or disconnect the points, and then the number of divisions that we want to add in between those. Okay? The pulley split operator, let me turn off the HDR so we can see a little bit better here, allows you to create a divisions in between your geometry freely. Okay, so if we actually clear this, you can use the pulley split to actually start splitting geometry. Okay, you can even put points in the middle of faces, that's okay. And choose whether you want to close your path or keep it open. Okay, all of these, similar to the curve sub, this string becomes fully editable. So we can come in here, for example, and adjust a particular location of a particular point. But this is basically a value that goes in between 0 and 1. So we have, because we're doing this, but let's say, for example, go to 0.5 here. You can see how the point is moving there. With this, you can actually see how we can actually slide the point up and down on the division that we added. This particular string that we have here is actually documented on the help card, and you can even write scripts or vets functions which actually create these scripts procedure, these lines procedurally. Okay. Oops. Okay. The solve operator will allow you to dissolve edges. There's a selection, so if we pick several edges here, we can dissolve them, which will actually remove the points to. If we actually went to come here and added even these edges right here, the reason why these ones don't get dissolved is because of the fact that these need to be selected as well. There you go. You can also choose to remove inline points, or whether you want to delete non-selected if you wanted to keep the other ones. Okay. Again, same thing, you can also fit it on edge group if you wanted to do this. Edge collapse, that's what you will imagine. If we actually come here and pick some edges to collapse, let's go ahead and actually just pick, not even that one, let's pick this one and this one. And that's what basically edge collapse does. Very simple. The visibility SOP is interesting. It doesn't actually delete geometry, but it allows you to hide primitives. So this is just a means for actually hiding faces temporarily. Okay, so they're not deleted, they're still actually there, they're just hidden. Several primitives which are not displayed. Okay, and moving along, let's take this sphere right here, and then I wanted to show you some of the UV operations that we have here. Okay, actually this is the old UV quick shade. Let me bring the one from Houdini 15 so we can see in the less colorful UV grid that we have here. Okay, so UV quick shade is an operator which you can use to very quickly add a UV texture grid to your meshes. Okay, if your mesh has UVs, it will just use the UVs that you have. If it doesn't have UVs, it will do a projection for you. Okay, and you can use the gray grid, or you can use the colorful grid that you saw there. Okay, for these operations, I'm gonna go ahead and actually split my view into two, so we can see in this particular case my UV viewport. Okay, so we can see what was actually happening. Okay, so here is my UVs and here is my 3D mesh. The UV project will allow us to actually do all sorts of different projections. Okay, so we can do polar projection, an orthographic projection, cylindrical, toroidal, etc., etc. Okay. There is also a UV texture operator, which is a little bit more vanilla and very useful, which allows you to do the same thing, but if you're actually dealing with a NURBS mesh, and I'll show that in a second here, you can also do, for example, per face UVs here. See that? You can even do, it provides just a few more options, I feel, like the actual UV project. But most importantly, say for example we had a NURBS sphere, which, if you guys know, NURBS have already a UMV, a sense of a UMV coordinate. If we feed this into a UV texture, and we actually went to arc length spline, it will create perfect UVs for this particular shape. It's actually one of the reasons why it's still very advantageous in Houdini to use UVs, to use NURB surfaces whenever possible, or parametric surfaces, because you literally get the UVs for free, which is pretty awesome. So I highly recommend, whenever possible, to try to always keep your operations from the simplest shape, which is like a curve, push all the way into an actual patch, and actually use arc length spline UV for actually doing these kind of like very quick UV operations. Okay. But moving along, let's take a look at some of those operations. UV unwrap will actually do a plane-based unwrapping of your UVs, such as this. It allows you to do control a few things, such as the spacing in between the actual, shells, and even be able to rotate your actual plane, which you're using for the projection. And UV layout will take a collection of shells such as this and actually lay them out in the neatest possible way. Okay, so if I actually went back to my UV unwrap and set mine and add more shells, you will see that UV layout will try to keep the least possible space in between them, unless obviously controlled by the padding, to keep things force things to take the most possible UV space. Okay, it has different packing methods. You can do single tile, you can force a scale, which is also very useful if you needed to, for example, fill the space a little bit better. You can also use UDIM, which is an attribute coming from 3D painting programs, which allows you to lay shells in different tiles or to force things in a single tile. Okay, so a lot of really powerful operations for actually doing, UV space. You can also use a UV transform to simply, well, as you can imagine, transform the UVs, just like you will use the transform to transform geometry. And UV fuse is similar to it's very similar to the fuse SOP, that it fuses UVs. Now the thing to keep in mind about it is that it doesn't care about border UVs or no border UVs. It will simply use merge UVs. Okay, you can specify groups to limit some of those operations, but this is actually an operator for fusing UVs based on distance. Okay, I'm gonna just do a clip operation here to show you some new operations that we have here. The pelt operator allows you to specify either, or not, or if you want to, you don't have to, but allow you to specify a shape, such as a plane, which can have some UVs. You can modify the shape of that using, for example, the UV brush, and then use that to actually force your UVs into that particular shape, such as if I actually modify the shape, my brush here, the pelt is actually updated to reflect. So, okay, you can choose the number of iterations that the mesh is pelted, so it will actually generate very, very, very undistorted UVs. And you can also choose to actually stretch how far you want to stretch out. It's a lot like, literally like pelting skin. Okay. Now you saw me using the UV brush, which allows you to just come in here and you can even brush your UVs. It's a nice way to very quickly edit UVs if needed. You can also use it in the 3D view, which is a nice perk. This is something that has been available in Houdini for a long time, but because Houdini treats attributes just as attributes, there is no difference on doing these operations in the 3D view versus the 2D view. Okay. And UV flatten will actually do what is called LSCM unwrapping of your UVs. With this operator, you can also set vertex pins. So, for example, you can actually add a pin and put your pin wherever you want, which will allow you to then force how do you want to bias your unwrapping. Okay, so you can force enforce border edges whichever way you want, and then have the LSTM unwrapping actually take care of making sure that everything beyond those borders is actually kept perfectly as distorted as possible. LSTM unwrapping is probably one of the best unwrappings that you can actually use for this kind of thing, these kind of operations. But this is basically what UV unwrap does. UV flatten does. Cool. Moving along to a few more, and then I'm gonna go ahead and actually switch this back to single view. Here is a tube operator. Let me switch my display here back to polygons. There we go. Here is my tube operator that I'm using again. What I want to show you here is how we can actually use the lattice operator, okay? Lattice operator there is a shelf tool for, so you can actually grab any object, okay, such as this tube really. I'm actually starting a new tube, so we can see this a little better. And I'm gonna make it polygons. Put the end caps at a few divisions, and at any point you can actually go to the form on the shelf and actually choose a lattice. Actually I think it may be under modify perhaps. Actually you can should be able to even do it in here by pressing tab and actually tap in lattice. There we go. Which is gonna then ask you to pick the points you want the form, and then that creates a lattice for you. Okay, this is what it created. You can see a little bit of this more in the some other tutorials. But basically, the shelf tool is just creating a little network of nodes for us, and I'll show you a little bit of what's going on. Okay, I want to show you here where I actually dissected these operations. So here is our tube. Here is a bound operator. The bound operator you saw before can be used to actually get a bounding box of an object, but if you turn on divisions you can use it to create something that looks a lot like a lattice. Okay, this is adds divisions down the volume of the actual bounding box to create almost like lattice type operations. We can even add enforcement bars, for example, if we wanted to use this with a polywire sub to make it seem like you have some kind of building structure of sorts. Okay. This particular case, I'm going to show you how this works with the lattice. Okay. So once we set that up, we pass on the first input the lattice on the form. Okay, I'm going to mute to set it. On the second input, we pass the same bounding lattice, but with modifications. Okay, so if we click on this edit node, as we modify the points on the lattice, this will actually softly modify the mesh underneath. Okay, this is also the same operator that you would use if you were actually doing wrap deforming. Okay, but that's basically how the lattice operator works. Okay, another useful operation is the sort operation. Okay, the sort node will allow you to change the order of primitives or the order of points in your mesh. Okay, so if we put no change, this is my point IDs. If we switch it to sort by the Y, now the higher the points are, the higher their indices are. If we reverse it, now the higher the point is, the lower their indices are. Okay. So any different ways that we can do it. We can even set it to a proximity to a point. So this is the closest you are to the origin, the lower your number is going to be. You can also give it sort based on an attribute, which can be useful, for example, to resort a particular mesh based on some rule that you set from before. Okay. So that to not change, and then I'll show you. You can even do the same thing to the actual polygon numbers. So if we wanted to change the order of the polygons, we can, for example, sort them out by the edge side, and so on and so forth. So a lot of really powerful things that we can do here. Okay? Now for the next one, what I like to do is to actually go ahead and turn this off here. So for next one, what I like to do is, let me set this back to reverse, okay? And I like to actually mute the next operator. Now the blend shape operator allows me to blend in between two meshes that match topologically. But in this particular case, because I changed the indices of the actual tube that I modified to the lattice, my blend shapes are breaking. Okay, obviously I can mute this. You will notice that now my blend shape operator will just work. Okay. By the way, the blend shape operator is set up with a multiple input so that you can feed as many of these matching topology blend shapes as you want. Okay. But let me just show you a little bit how this works. So if we actually turn on this so that the blend shapes break, at any point if you have a mesh where they have the same point counts or the same primitive counts but their topologies don't match, you can always use the match topology to force them to actually match topologically. Okay. What you do here is that you provide some tracking points on the left mesh and some reference points on the right mesh. Okay. What that means is that if we pick, for example, let me just show you this. Looks like this is just working right here. But if we were to, for example, come here, we can say, okay, you know what? Let me hide this. Let me show the point numbers. And let me also, on the tube, I'm going to turn off the end cap so we can see this a little bit more clear, okay? I want to match 0.4 and 5 on my left mesh with, on this mesh, oops, with the mesh over here. And this is actually still up because of the match topology. So I'm going to match, what I meant to do, sorry, is to actually match points 95 and 94, okay, with points from the original tube 4 and 5. Okay. Now we'll go to match topology. You'll notice that point 4 and 5 are matched here, because what it's actually doing is saying, okay, grab those 2 points, match them, and then continue following to all the points on the mesh until they all match. Okay. This will even match their topologies in between multiple islands if necessary. Okay. So now when we go to blend shape, our blend shape will actually work. Unlike a lot of other applications, Houdini gives you a lot of control on the way how the meshes are actually sorted, one, so that you can actually have a ton of control on this. Also very useful is the ray operator. The ray operator will allow you to ray cast on the points so that you can actually intersect points against other shapes. Like in this particular case, we have a grid. Okay, and we're simply just ray casting my tube to the grid based on the closest point. Okay, you can do it by the closest point, or we can do it, for example, in this particular setting based on the normals. Okay, so basically if the normals actually hit the surface, then they will actually hit. If they don't, they won't move. Okay, and also very importantly, use this operator to create a group of points that actually hit and points that didn't hit, in case, for example, we wanted to use the blast node to delete the points that actually hit, or vice versa. In addition to also create be able to transfer when a point hits somewhere, the code for an attribute where it hits. So for example, if my grid actually had some random colors, let's do that, and then we'll add some random colors, you will notice that where the points hit, they will actually pick up the colors of the intersecting points. This is all fully persistent, so as I actually move the grid, you will see that the snapping ends, and also the points are, the colors are actually being transferred. Now the thing to keep in mind is that they're not picking up the colors of the closest points. This is an operator which finds the closest surface point. So it's actually picking the interpolated fragment at that point. Okay. and it works with any kind of curve. It could be a curve, it could be a curved surface. It doesn't have to be a flat plane. But basically all of these operations will work as expected in this sense. Okay? Very cool. Moving along, and we're almost done. Here is actually, I just wanted to show you some of the manual operators that I have in Houdini for editing meshes. So here is a torus, another one of our primitives, and the edit operator puts Houdini into a what I like to call ZBrush mode, where basically we can come in here and start operating on points as if we were actually just sculpting inside of an application such as ZBrush. Okay, multi-selection works just as you will expect. We can even do things, and we can obviously adjust the edge, soft edge radius right here. Okay. There's a lot of different things that we can do here. So just for example, we can switch the mode to, we can turn on slide on surface, which will ensure that as we're actually moving operations, they're actually all sliding and staying on the surface. Okay. We can also switch to pick mode, which will simply, wherever I pick, I can basically leave polygons down their normals. Or even just switch to like brush style sculpting, which when I switch to points, this will allow me to actually just play my operations like this. Actually, we have a group here, which is what is actually keeping that from happening. So we can actually go in here and actually just sculpt with a brush. Okay, so different operations that we can do. The thing to remember is that this is fully persistent. It is actually based on the IDs, but if you have a predictable order of rows and columns, for example, in this case, the operation should actually still somewhat match what we want. Okay, it can get a little crazy, so keep in mind the order of your operations and the polygon count. Okay, at any point we can always obviously mute it, so it's always non-destructive, so we have access to all of that. We show UV quick shade. That's just because I wanted to show you UV edit, which is the equivalent of the same operation, but you can do it on UVs. This of course you will do in the UV viewport, and it will be just like the edit SOP, except that we'll be doing it on, this will be working on UV space. Okay, very cool. And moving along, this is a very simple operator. The switch operator will simply allow you to switch in between multiple inputs. Okay, so in this case I have 3 inputs, and you will see that any input that I add there, we can switch in between them by simply switching this slider right here. It's very, very simple. You can put, anytime that we see an operator which has these 3 little arrows here in a single plug, that means that we can keep plugging things in as much as we want, and it will just keep adding in these big bots here. These bots right here also allows us to reorder, for example, the inputs if we wanted to, or even disconnect an input right here if we wanted to as well. So cool. Here is another very useful operator which I use quite a bit. I'm going to show you here. First I'll like to use a duplicate to create a duplicate of my actual circle. And then I like to show you the scatter operator. The scatter operator is an operator which allows you to scatter points on any surface. Okay, it doesn't have to be a flat surface. It can be even on, full 3D surfaces. Okay. It is useful to then be able to have these points here to instance objects on it, for example. And obviously there is a lot of controls that we have, such as the number of points that we're scattering. Also, we can play with the seed of the points, or even choose whether we want them a little bit more scattered or a little bit more even and relaxed. Okay, so different ways so we can actually do the scattering. Okay. Can also provide a radius for scattering and the maximum relaxed radius if we wanted to actually control it that way. But I want it now. The triangulate to the operator is can be a bit deceiving sometimes of the name. This is something that you can use either on geometries, but it's normally used on point clouds. What triangulate to the operator will do is take a point cloud like this and connect all the points with what is called Delanoy triangulation. Okay, Delanoy triangulation is one of the cleanest possible triangulations that you can have. Okay, it's based on algorithm which checks for checks that every point has the proper connectivity with all the other points to create the most ideal possible circle. And it's a very useful way to actually get geometries shapes out of like just point clouds. Okay, it is of course a fully persistent operator, so as I play with my actual poly count on the scattering, which by the way we can also do by attributes or by area, all of this will still work. We can even still move the duplicated circle that I have here, and look, even as they overlap, geometry will start really nice, triangulating very nicely, okay, and completely seamless. It's almost like a volumetric effect, if you will. Okay, this will also try to match the ideal plane as much as possible. We can even do things, for example, such as provide a constraint edge or constraint primitives. So for example, for constraint primitives, if we put circle, if we put both circles here, which is actually primitive 0 and primitive 1, looks like it actually wants a group. Let's actually go ahead and select my circles. Oh, that's right, it's because let me escape this state. Okay, so basically the problem is that we don't actually have primitives because we're actually passing a point cloud. But let me show you this really quick. So like I mentioned before, the triangulated, it doesn't have to work on a point cloud. It can also work on just the circles themselves. So we can take the circles and do a triangulated in, and it will triangulate them so that you get the perfect triangulation in between them, like I mentioned before. Okay, so now the thing to keep in mind is that in some cases you may not want that those triangles that are in the center here. You can actually add constraint primitives to this, which will then take the incoming primitives, in this case the first one and the second one, and force the triangulation to only happen in between the specified primitives. You can even say only triangulate one of them. This will then filter the triangulation so that it never goes over that. Okay, should be able to still come over here and move this so that we can see the effect of them actually coming closer and how the triangulation actually handles keeping those two primitives together. Okay, very cool. You can also provide constraint edges if we wanted to force the triangulation to always keep certain edge loops. The difference there is that if we move this back out and we turn off this, adding saying that I want all my edges to be constraint edges, notice that it doesn't care about keeping the and trying to delete this, but it ensures that no matter what happens, we will always have these edges right here. Okay, you can also allow these to actually, you can also add these to actually add refinement if necessary by specifying a minimum edge line, and also specifying a maximum area for the triangles. Okay, so a lot of different options that you can use for actually playing with the Delanoy triangulation. Okay, now moving over here, now here is our test geometry big head. Houdini 15 also ships, and I believe 14 also had this. If we go to test geometry, you have several geometries that we can play with. So for example, we have a shader ball. We can also have a pig head, which we're all very familiar with. But there is a few others that you can actually try out. Okay. What I wanted to show here is that here is a scatter on a 3D mesh, and we're actually scattering point on a 3D geometry. And the tetrahedralized SOP is basically the 3D equivalent of the Delano triangulation. I said that is creating tetrahedrons and connecting all the points across the mesh, inside and outside. You can switch it to doing tetrahedrals. Tetrahedrals are basically just like a triangle is a primitive polygon triangle, a tetrahedron is also a primitive. And in fact, I can use a blast stop and set it to only show me tetrahedron number 0, which looks like that. And as you can see, it looks, it looks just like a tetrahedron. Okay, as we actually move this, you'll notice that we can see all the tetrahedrons that makes that complete network of tetrahedral meshes. Okay, you probably guess by looking at this is a very useful way to create simply a convex hull of a mesh. It works also on not just point clouds but on regular meshes. Okay, and this will allow us. This is also a very great way to very quickly generate collision meshes, which we can use in a, for example, in a game engine. Okay, it's also a very useful operation with the tetrahedral that it can also mark polygon intersections. So if we have the original mesh here, and obviously this mesh doesn't have intersections, but if we actually were to merge these two together, and cause them to intersect, so by actually making this bigger, you will notice that in the areas where they intersect, the tetrahedral SOP will actually start marking any polygons where there is an intersection. It's a very quick, cheap way to actually calculate intersections and between polygons. Okay, and I think that should be it for now. I think this actually covers quite a few operators which you can use, and then I will encourage, of course, to continue to explore and try different operators yourself, and just experimenting with different combinations of these to see what results you get. Thank you for watching, and then we'll see you in the next video.